Welcome back to AER channel, and welcome back to sheet metal series. So far, we've learned how to create a base flange in order to start our sheet metal part. And we've looked at the sheet metal properties, things like the bend radii and the K factor. Now, before we actually start getting into how to add features to the base flange, we are quickly just gonna look at two common materials, steel and aluminium, and then have a brief look at three slightly less common ones, so we can see which might be best for our different jobs and different parts. This isn't an exhaustive list. There's many other materials out there, but these are the most common ones. Probably the two most common are aluminium and steel, and these have both got a number of different advantages and disadvantages. Let's take a look at steel first. This is probably the most common sheet metal material. Steel's a great all-around material. If you're not really sure what to use, then steel is usually a good bet. The main advantages of steel: it's very strong, so it's often used for things like car bodywork, but aluminium is becoming more popular there. Steel is also quite ductile. That means it's easy to bend and form into shapes, and it's also quite cheap compared to other metals. This really depends on the world market, but it can be up to 3 times cheaper than aluminium by weight. And then finally, steel is a little bit easier to weld than aluminium. Some of the downsides of steel are that it's quite heavy. It does depend on the exact grade of material that we use. But in general, steel can be about 2.5 times more dense than aluminium. So if we've got two sheets with the same thickness and size, then steel will be much heavier than aluminium. Another downside is that it doesn't really have great corrosion protection. I'm sure we've all seen rusty steel items, maybe things like old cars and things like that. But basically, this rust is a reaction between the metal, the oxygen, and water. And this eats away at the metal, so eventually weakens it and eventually completely destroys it. We can counter this with surface treatments, things like galvanizing. We might have heard of galvanized steel, or even by painting. But other metals like aluminium are much better at naturally resisting corrosion. The next major metal is aluminium, and this is used a lot. It's used for things like drink cans, bike frames, and some cars. And it's also used a lot in aerospace components. And that's because compared to steel, it's very light, as we just mentioned earlier, and also it doesn't rust. Aluminium is very malleable, so it can be bent and formed pretty easily. I'm sure we've all seen aluminium foil and just how flexible that is. But the downsides of this, as we just talked about with the steel, are that it can be much more expensive than steel. It's also nowhere near as strong as steel, so if we cut two parts for the same job, then the aluminium one would have to be quite a bit thicker than the steel one to have the same strength. But on the plus side, as we just mentioned, it is actually lighter. So it depends on the exact type of metal, but generally aluminium does have a greater strength to weight ratio than steel. Those are the two main metals we are likely to see. There's also some other fairly common ones. One of those would be copper. This has good electrical and thermal conductivity, so we often see it for electrical parts, things like wiring or battery contacts. It's also got good corrosion resistance, but it's still quite malleable, so it's often used for things like plumbing fixtures, pipe, and so on. It is quite expensive though. So some countries have a problem with thieves stealing copper wiring from things like telegraph poles or electricity substations, and that's because we can sell it for a very high price to a scrapyard. Similar to copper is brass. This is basically an alloy of copper and zinc, so a mixture of copper and zinc. It's pretty similar to copper really, but it's got this bright look to it. So it's often used for decorative things. We sometimes see for door locks, hinges, utensils, trinkets, and things like that. It's similar to copper in that it's very malleable, so it's good for making musical instruments. We might have heard of part of the orchestra, which has the trumpets and so on. It's called the brass section. And it's good for these instruments because it can be folded a lot and worked pretty easily. And it's also similar to copper, that is very resistant to corrosion, so we often see it for the things like handles on old ships. And then finally another metal is stainless steel. This is basically steel that's alloyed with other metals, chromium or things like that. And this stops or slows down the corrosion process. So if you want the benefits of steel, but you don't want your parts to go rusty, then this can be a really good option. Often you'll see it in things like cutlery, so knives and forks, and things like surgical equipment. In terms of sheet metal, we might see large items like kitchen equipments, sinks, kitchen counters, cabinet doors, and so on. But the downside with stainless steel, because with materials everything is always a trade-off, is that it's much more expensive than standard steel. Obviously there's dozens of other options, even things like tin, nickel, titanium, even coal. But these are all fairly minor issues compared to those first 5. Within those main materials, there's also many different grades and subtypes, so it's probably best to speak to your manufacturer and see what works best for your own needs and for your budget. As we touched on in an earlier video, these sheets of metal are often sold by the gauge, which is the thickness. So a higher number means a thinner sheet, and the gauge depends exactly on the material. So 16 gauge steel, as we said before, is a different thickness to 16 gauge aluminium, and then both of them are different to 16 gauge zinc, and so on. Just to repeat one last time, I'd recommend not using the gauge and actually specifying the thickness in millimeters or inches. That just avoids any confusion. As well as the thickness of our metal, we might also need to consider the sheet size. There's a number of standard sizes. These can be metric or inches depending on where we live, and some of the common ones are shown here. It might be worth checking this sheet size first if you've got a very large part or if you've got many small parts that you might want to nest onto a single sheet in the most effective way. So this covers metals fairly briefly. To quickly summarize, steel and aluminium are the two most common. Steel is strong, cheap, easy to work with, but on the downside, it's pretty heavy and it can go rusty. On the other hand, aluminium is expensive, but it's light and it's got a good strength to weight ratio, and it's very easy to form. There's a few less common ones like copper and brass. They're very good at conducting heat and electricity, good at resisting corrosion, and they're very malleable. But on the downside, they are expensive. And then finally, stainless steel. It's got a lot of the benefits of steel, but it's also expensive. The metal thickness can be specified using the gauge number, but I recommend you actually specify the thickness and then just double check your actual sheet size. There's a number of different standard sizes around the world. So there's a very brief introduction to materials. In the next video, we are going to start looking at actually adding new features to our base flange. Thank you for watching. Please subscribe if you like. Hope it can be a little helpful and useful.